Hello guys and welcome back on this new video on our C++ series where we're going to discuss a little bit about the foundation of pointer with C++. A pointer in C++ is a variable that stores the memory address of another variable, enabling direct access and manipulation of memory. How pointers make C++ special? Pointers give C++ low-level memory control, allowing direct manipulation of memory, unlike languages like Python or Java. Dynamic memory allocation with new and delete, as you're going to see in the few examples in a couple minutes. Efficient array and structure handling. Implementation of complex data structure like linked list, trees, and so on. Function pointers for callback and custom behavior. This level of control makes C++ powerful and performant, especially in system programming, game development, and embedded system area, where other high-level languages fall short. Let's see right now how to declare a pointer variable. Initializing pointer variable to point nowhere is the best practice. But before that, let me explain how the structure is. We are reading, for instance here, a pointer declaration from the right side to the left side. We're going to define pointer name pointing on the variable type, and we're going to initialize it to a new pointer if we don't have a special value to that pointer. Okay, so that's how we are declaring a pointer pointing for an integer, for example, on this first line, by integer pointer pointing on the integer type, and we have initialized it to new pointer. Okay. On the next example, I'm doing the same with double type, double pointer pointing on type double, and I've initialized it to new pointer, which means it's pointing nowhere. I'm doing the same for a character pointer pointing on the character type, initializing to new pointer, and the same for string as well. Okay, so that's a little bit it about how we proceed to initialize a pointer generally. Okay, so let's jump on our code line interface quickly right now. Okay, and we're going to work on a couple examples. Okay, first, how can we proceed to access pointer address? Okay, it's our first topic here, accessing pointer address. And for that, I've defined this example that we're going to run through. Okay, so I've initialized first in my main function the num variable of type integer, and I've initialized it to 11. Okay, so on the first line, I'm going to print the value of num, and I should receive 11 exactly because I pass it right there in my print cout function. After that, we're going to display the size of num. Okay, and normally the size of num should display the value of integer type function in our system. Okay, it can be 4 on some computer or it can be different depending on the system that you are using. Okay, and on the text example, I print the address of the variable num. Okay, and the end character that I've added here going to allow us to print the address of our variable. Okay, so that's a little bit it about what we're going to call the reference and so on. We're going to discuss more about it in the few minutes and in the next video on this series. Okay, so when I'm going to print that reference, that address of num, that's what I'm going to receive right there. Okay, and that's a little bit it about the concept on how to get the address of a variable that is going to be really useful on the next step, okay? So let me compile this quickly and execute it, and you're going to understand what I'm talking about. You see? So we have exactly what I was talking about, okay? The size of variable of type integer on my computer is 4. That's why I have 4 here. And address of num is, this is the address of this variable in the memory, okay? So that's this is the address where this integer is stored in my memory, okay? So this is the first introduction about how to find an address. But in the next example, I'm going to implement some pointer, and I'm going to display the address value as well. I want to display the value of my pointer and the size of my pointer, okay? And you're going to understand more about that pointer concept, okay? So let's move on our next example right now, where we're going to initialize our first pointer, okay? Let's do that. So right there, I have my new quick code, okay, where I'm starting by initializing a pointer p, okay. Right there, I just declare my pointer, but I didn't initialize it. So normally it should point nowhere, okay. When I'm going to display this first line, you're going to see that you're going to have garbages because I didn't initialize this pointer. For that, let me comment this section first, okay. And let's compile this. Let's rebuild it to make it easy. So rebuild normally, clean and compile. Okay. Pay is used on initialize. So I have a warning alert here. I'm talking about warning alert in C++ in our previous video. Okay. It's talking me that I didn't initialize it. So that's why I'm going to have garbage when I'm going to try to execute it. Value of p is 0. Okay. So it's not true. This is some kind of garbage, okay? So let me move forward, okay? I'm going to take this one out here and put it over there, okay? And I'm going to try to print the address of the pointer p, okay? I've defined the pointer p pointing on an integer type, okay? So let me do that quickly. Address of p is, we have the address of our pointer that is displaying using the n. You remember the n character that we used before, okay? That's how we can have the address of our pointer, okay? Now let's check the size of p of our pointer, okay? Let's see what is the size of a pointer on my system, okay? So we're going to process same, compile and build and execute. The size of pointer on my system is 8 byte, okay? You can see that it differ from the one that we have for integer in the previous code, right? So even if our pointer is a integer type, you can see that the size of a pointer is different, okay? It's greater than the size of a simple integer, okay? So it's really important. Make sure to understand all these basic concepts because they are going to be really helpful for the next step. Okay, now I've defined p, okay, my pointer value to new pointer, okay, and set. So when I define it like that, when I assign the new pointer value to my pointer p, this one set p to point nowhere, okay, and I'm gonna see out I'm gonna see out the value of p on this last line after initialize it to new pointer, and let's see what we're gonna have. Awesome. We always have we still have 0, but I can guarantee you that this is the better practice. We still have 0, but this 0 is specified, okay, it's specified. It's not the same garbage that we have over there. Normally on some system you should have different value. You should have some garbage stuff that looks weird here, and you have a 0 here, because new pointer normally is the best option to point on. Nowhere is the best option to point to 0, okay, but it's not that much a big deal. I hope that you understand a little bit the basic stuff about variable, integer pointer, how to get the address of an integer pointer, how to assign a specific value um, using a assigning process, like we have assigned the new pointer to p, okay. But let's move on our next example right now, where we're going to discuss a little bit more about that new pointer concept. Okay, in this next example, we're going to be able to experience better how pointer is working. Okay, let's uncomment it quickly, and let's see. Okay, so first, I've defined my integer variable score, and I've initialized it to 10. I also do the same for a double variable I_score. I've initialized it to 100.7. Then I've declared my integer, my score pointer pointing on integer type, and I've initialized it to 0, new pointer. Okay. After that, I've defined the score pointer. Okay. I've defined it. I've assigned the address of score integer variable to my score pointer. Okay, that's why I'm using the n. Okay, the n character right there. Then when I'm going to try to assign the double address to my score pointer as well, you can see that I have a warning here. I have an error. Incompatible pointer, you see? Incompatible pointer types assigning to int pointer from double. Why? Because I've defined my pointer as a integer type. Okay, so there's no way to assign a double address or a double value, no, a double address to a pointer that I've defined as a integer type. Okay, so that makes sense, right? So we're going to have a compile error here. I just keep it to make you understand that there's no way that we can do that. So let me clear it up. Okay, so now, if it's what you should keep in your mind is, if you have defined a pointer type in a specific type, make sure to attach or assign a value that gonna respect the type that we have defined. Okay, so that's a little bit it about this first part. Okay, now how to proceed with the differencing process of a pointer, how to differencing a pointer. Okay, to differencing a pointer, most of the time we're just going to use the pointer sign in front, then the name of our pointer. Okay, so let me explain it here. Right there, for instance, I've declared the integer score, okay, and initialize it to 100. After that, I've declared and initialized the pointer score pointing on type integer to address value of score. Okay, then we're going to print the pointer score pointer. Okay, we're going to differentiate our pointer using the pointer character here on the beginning. So you're going to see that we're going to have exactly the value that is contained at this memory address that you have initialized here, which should be 100. Okay, and after that, I am assigning here a value to my score pointer variable using the same processing. Okay, and I've assigned to it 200. And you're going to see that see out when I'm trying to print it right now. Normally, it's the update value that I'm going to have here. So the differencing process going to allow you to display the value of a current uh, pointer, or you will be able to you should be able to modify as well the value of a pointer using the differencing process. Okay, so that's how I'm modifying it here, and you're going to see that when I'm printing hit here, you're going to see that you have exactly uh, uh, 200 right there, and over there we should have the same address that we have defined on the beginning, or the same address that uh, our integer score has since the beginning of this code. Okay, let me comment this quickly to avoid error, because I'm not going to use them here. Okay, so let me compile this and execute it quickly. You see that, right? So on the first print, I print the value that is stored on the address of this where this pointer pointing to, which is this address, and it's 100, right? After that, I've assigned 200 to our score pointer value, and when I am trying to display that value here, I have that 200. Okay, and after that, automatically, when I'm trying to print the score value on top here, that value has changed, right? So it's 200 that we have right now. So that's a little bit it about this example on differencing a pointer. Okay, I hope that you were able to understand how differencing is working basically. Okay, right now I'm going to move on another example where we're going to talk a little bit about dynamic memory allocation. Okay, how to allocate dynamically a pointer, a value to a pointer, how to delete it dynamically as well, and so on. So for that, I've write this code. Okay, so dynamic memory allocation. Okay, as I said in the definition, we're going to use the new to allocate storage in memory in the heap. Okay, so let me uncomment this first. So first, I've defined right there my integer pointer pointing on the integer type and initialize it to new pointer. Okay, after that, right there, I allocate an integer on a heap dynamically using this. Okay, integer pointer equal new integer, new int. Okay, so that's a little bit it about the process to allocate an integer on the heap dynamically. Okay, we're going to define most of the case first, our integer pointer. Then we're going to allocate an integer on the heap, okay, using the new int. Okay, so we use the name of the integer that we have defined and we use the new int in order to allocate an integer on the heap. Okay, then when I'm going to see out integer pointer, okay, is this one that we're going to have. Okay, so let's try to move forward. See out the integer the value of the integer pointer normally should provide a garbage, because right there I think that you should receive the address that we have created in the heap here. But right there, if I'm trying to display the value using differencing, I'm going to receive some garbage. Okay, then after that, I'm going to define my integer pointer. Okay, I'm going to use the differencing process to allocate 100 as the value. And when I'm going to see out the value again, you're going to see that I'm going to have that 100. Okay, so let me fix this first. Okay, so let me compile this and execute it quickly, and let's see what we have here. So you see, the first see out integer pointer here is showing up this memory address because we have allocate integer pointer, we have allocate an integer on the heap, right? So when we are trying to display the value of our, when we are trying to display our pointer, normally is the value that we're going to have here. Okay, so this is the value, this is the address of our pointer in the memory, in the heap. Okay, in the heap section of our memory. Okay, then when I'm trying right there to see out the value, okay, using the differencing process of our integer pointer, is garbage that we got here because we didn't initialize it yet. Okay, and after that, I'm using the differencing process to initialize, to assign the 100 value of the to provide the 100 value of our pointing address in the heap. And when I'm trying to see out this value again, you see that you have 100, right? So if you have a question, if I'm not clear about my explanation, provide your question in the comment and I will really happy to help. Okay, so that's a little bit it about the introduction on how to allocate uh, uh, um, an integer on the heap. Okay, how to allocate dynamically an integer. Okay, so right now I'm gonna use the delete option to deallocate storage. Okay, so it's the best practice when you allocate storage in the heap. always deallocate it when you're done. Okay. Normally, so let's see right now how using delete to deallocate storage. Okay. Normally, once you are define your pointer and you allocate an integer or you allocate a memory in the heap using the new, the best practice should be always to use the delete option in order to clear it up. Okay, so the delete integer pointer after everything should freeze the allocate storage. Okay, so this is the best practice after all your code and so on. So right there, I'm just trying to explain how it's working, but we're gonna run a good practice right there. Okay, so right there, for example, I've initialized my integer of type array pointer. Okay, I have my array pointer pointing on integer type. Okay, and I've initialized it to 0, and I also declare my size integer, and I've initialized it to 0 as well. After that, I print how big do you want the array. Okay, and I'm going to keep the output in the size variable. Okay, then I'm going to allocate array on the heap using the new int, passing the size variable as parameter. Okay, in the bracket. So array pointer equal new int size. Okay, that one gonna allocate arrays on the heap. Okay, then after that, I'm gonna proceed with delete. Okay, delete pointer to delete an array using the dynamic pointer process. We should write delete, after that empty bracket, the name of our array and the semicolon. Okay, that's a little bit how that one is working. Okay, so I just keep that one as an explanation as well. Okay, so let's clear that one up and let's run through this real practice now. So in this example, I'm going to define my function. I'm defining my void function with that has as a parameter an integer pointer pointing on integer type. Okay, and this function should double the value of the integer pointer that we're going to provide. Okay, this is the purpose of this void function. Okay, so in our main function, I'm going to initialize a main value to 10. I'm going to initialize a value to 10, value variable to 10, and also a integer pointer pointing on integer type and initialize it to new pointer. Okay, then I'm going to try to see out the value by passing by value that variable. Okay, then after that, I'm going to call the double data function that you have defined upstairs and pass by reference value. Okay, and you're going to see what we're going to have here. Then right there, I'm going to define my integer pointer equal to the address of value. Okay, then I will pass again the double dollar, passing the integer pointer value, passing the integer pointer. Then when I'm going to see out it, you're going to see what we get. Okay, so let's compile this quickly and let's explain what we have here. All right. So when we see out value first here, you can see that we have 10, right? After that, I pass by reference value, okay? And you can see that when I see out value again, the value of value has double. It's now 20. Okay, that makes sense because our void function have has to propose to double the value that we pass to it, right? And on the next line right there, okay, I also pass the address of value. I've assigned the address of value of to integer pointer. So it's the last value that you get here, which is 20 that I've passed here. And you can see that when I pass again the double data function, and when I pass by value the integer pointer, automatically it's going to move and get what we get on that address, and it's 20. You're going to multiply it by 2, and that's why we have 40 right there. Okay, so that's a little bit it about the power of pointer in C++. Okay, I have tried to introduce it, but I want to come back on the deep concept around this pointer on C++ on the next episode. If you have learned something new about pointer, give me a thumbs up to this video and subscribe to the channel to make sure to follow all the next interesting episodes that are coming on C++ and everything about DevOps concept and software engineering concept. Thank you for watching until the end and see you for our next episode. Bye.